All right, so welcome back. And I am here today with a special guest. Standing here beside me is Victor Kuhns. Victor is a guy that we actually met at Pikes Peak 2016.
Yep.
And unfortunately, that year you had an engine failure.
Sure did.
But in trying to kind of get the car sorted, we actually brought you back here to the shop, tried to help you get up and running again. That didn't work. But through the course of that and in trying to get your car up and running, we've been in contact. And one of the things that has been really interesting with your car is the process of getting it put back together. And one of the reasons I wanted to bring you down here and talk to you is because you have done probably a more detailed analysis of oil pressure and then going through oil pumps as you have gone through the process of putting your car back together. So I wanted to kind of shed some light on that. So maybe as a start, so Victor, tell us just a little bit about the car and the engine that you're putting back together, just so everybody kind of have an idea where we're starting.
Certainly, yeah. And so for the folks watching, I've been watching myself with the videos, so this has been extremely helpful to go over all the bits. My car is a 2000 Impreza STI. It's got a couple of trick goodies on there. Originally, it was built in 2004 by Vermont Sports Car. And,
so it's a race car.
It is a race car. Okay. I've been doing rally since 2003 actually. So Pikes Peak was my first year was 2010. Okay. 2010, 11, and 16, and those are all long stories.
Right, right.
But the engine was originally done by ProDrive, so it's full of WRC goodies. It had WRC internals, the crank, rods, pistons, valve trains, so all kinds of secret recipe items inside.
And so when you had the engine failure, as you were going through it, you actually, instead of just getting a new engine and putting it in, you actually disassembled it, you looked at everything, and then you started on a new build.
That's correct. I had the opportunity to pull the engine apart and kind of understand, okay, why was it put together this way? There was enough that was still salvageable.
Yeah.
I was able to make measurements of the crank, the rods, to find out that the rods were unique lengths and certain bearing tolerances, every little minute detail to reverse blueprint the engine.
Right. So and if ProDrive built the engine, those are some good guys you'd want to get some secrets from for sure.
Certainly.
Yeah.
So, oil pressure was a big thing. I had been putting out a lot more power for Pikes Peak. I've kind of, had that bug that everybody else has in the mountain. Let's turn up the dial some more.
Sure.
So 2010, I started off with a lot less power, but throughout the years, the goal was to really see if we could bump it up and get up Pikes Peak a little bit faster.
Well, that's always the lure. You want to turn up the power and try to be more competitive.
Right.
Yeah. Now, so since we're talking about oiling, let's start with what was on the car to start. What oil pump was on the car?
I was running the 10mm pump, so it's actually the same pump that we have right here.
Just a stock 10mm
It was
pump.
the stock 10mm pump.
Okay. Well, and so this is an oil pump, and we've taken it apart, and let's just kind of just quickly go through how the pump works. So you bolt it onto the engine. You have the backing plate off, so this is actually the rotor that spins around to create the oil pressure. So in a stock pump or in any of these oil pumps, the oil comes in, the rotor spins around, and it basically as the rotor turns, the oil comes into the large cavity. It's sealed off. It's compressed slightly. And then basically as it moves over to the pressure side, then it releases that oil that's now been pressurized, and so it's sent into the engine. And so two things of note. One is, when you're talking about different pumps, so we've done another video, the 10mm pump, 11mm, 12mm, that is the thickness of this rotor. That's what they're talking about is the difference. So in the simplest sense of it, this rotor, if it's 10mm, that's the height of this column of oil. If 11mm, that's the height of that column of oil. So the larger the rotor, the thicker the rotor, the larger the volume of the pump, or the larger the volume the pump can move. And then the other interesting thing that we really kind of want to talk about too is the relief valve. Yep. So what does the relief valve do?
So pressure relief, right? Yeah. So if a certain pressure is achieved in the engine, so in this case, from online information, the pressure relief on the 10mm pump is 85 psi. Right. So after 85 psi, it bypasses the oil. So basically what's going on is the oil is just being churned in the pump.
Right.
And as it's being bypassed, it's actually heating up because we got friction that happens on the pump.
Sure.
So you kind of want to avoid bypass. You want to stay, it's the adjustment. So that's kind of that discussion, that we're leading into. What does shimming do?
Right.
Right. What do we do when we play with all of this, and what are the pieces involved with that?
Yeah. So the bypass, that's kind of the maximum pressure that the pump will hit. Because
Right.
once you hit that maximum pressure, then this valve opens, and that lets the oil then skip going into the engine and goes back around the pump. And these pieces here, we'll get a more detailed picture of it. But basically you have this piston that sits inside the pump here. There's a spring behind it, and behind that spring there's this bolt, which we'll show you on the front, that is applying that pressure, and then when it opens, you can actually see it moves all the way back here and opens up down here to let the pressure side, basically, or the oil that's under pressure, come from the pressure side back into the non-pressure side and then cycle back around.
So John, I think for volume on the pump, I think the YouTube with the 10, 11, and 12 millimeter pump was a great start to show the examples. So I think the important emphasis is that, we all go online, we read forums, and we really try to understand what's going on. And so pressure and volume, and really understanding the importance of pressure and volume.
And the relationship there.
And so with my specific car, I had my own experience to go through and see these observations for myself on my new engine.
Right.
So on my new engine, this time around, I went with larger tolerances.
So a bigger opening at the bearings.
Correct, on the main bearing and in the rod bearing. So that was set to different sizes than the original engine. And I noticed different behavior. So again, a lot of this was I spent some of the time to go through and try to understand, okay, given my current configuration, what am I seeing?
Power levels. Yeah.
So for volume and pressure, I think it's important just to, for folks that are, stuck on one of the concepts, just visualizing that sense. We have a snorkel and we have a 10-inch diameter pipe.
Sure.
Right? And on a snorkel pipe, right, it's probably, 1 inch in diameter.
Right.
We put fluid through there at X pressure. Let's just call it 80 psi.
Right.
Right. And then we also take a 10-inch diameter pipe and we fill it up to volume and also pump 80 psi. We certainly visually have a completely different volume. I could run
more volume.
Exactly. I could run the 10-inch pipe with significantly less pressure, but have a ton of volume behind it. Right. Versus this 1-inch pipe that has very little volume and a lot of pressure.
Right.
So that's kind of the observation of what we're seeing. As I opened up the tolerances on the engine, I basically created a bigger pipe.
Right, you're putting on a larger fitting. You're in another way to say it is you're reducing the restriction on the oil as it flows through the engine. So since you had the engine, you tore it down, you knew where you were starting, and you knew that the oil pump that was on there was a 10 millimeter pump. That's where you started. And so what did you see as you put the 10 millimeter pump back on, but now with these different tolerances?
So with the larger tolerances, this is what was interesting. I noticed initially, startup, the oil pressure was cold startup. We're at about 85 psi, and once the car got warm, it kind of settled down to about 70, 75 psi, and that seemed to be pretty normal for my setup. As I started driving the car and introducing road temperature heat, and spirited driving.
Sure. Gotta break it in somehow.
Exactly. I started to notice that the oil pressure was dropping. So I think an important piece for me, kind of just understanding my own environment, is that I had an oil pressure gauge and an oil temperature gauge.
And those are the two, if you're going to start looking at anything to do with the oiling system, those are the two basic pieces of information that you have to have.
You have to have both of those, and they're just fantastic on just giving you a vision of what's going on.
And to be fair, when you put those on, getting a baseline, knowing where you're starting, that's also hugely helpful. So fortunately, you've been running those gauges before. You knew what it was before with the old engine. Now you've got the new engine that's slightly different tolerances, and so you could see that, hey, there's a difference here. The pressure is at road hot. It is not what it used to be quite.
That's correct.
So that was the indication that, hey, something has changed enough to the point where if you want your target pressure to be to a certain threshold, you have to look at a change. Right. So that's when the shimming comes in. So this is something that's talked about a bunch, but it's a little bit, maybe a little bit hard to understand, but it's really couldn't be simpler. So you have this piston that is, the relief valve, and then there are these little washers that are, or shims that are stacked in here to push up against the spring. So basically, as you're shortening, or basically as you're compressing the spring more, you're increasing the tension on the spring, and so if you stack more washers in there, you compress the spring more, you're increasing the spring tension, and by doing so, you're increasing that pressure for the relief valve.
Correct. And technically, it increases the pressure of the relief valve, but it also brings up the bypass pressure.
Sure.
Right. So we're now going past the 85 psi range.
Right.
So you go on the internet, you see a lot of there's a lot of discussions. You do this, do that, 1,000 RPMs, 10 psi per 1,000 RPMs.
Right.
What are these pieces? So again, in my situation, what I was noticing at street temperatures, hot, and I think we find this a lot in the forums. People are like, oh, I see this pressure hot.
Right.
I really feel track temperatures and street temperatures are two different things.
Sure.
And at street temperatures, I thought like, well, that's okay. I'm okay with this because my oil temperatures seem to be reasonable. I'm seeing 200 degrees to 210 on oil temperatures on the race car. But at track temps, I saw a completely different deal.
Right. So what temperatures were you getting at?
So at track temps on my car, with the way it's set up with the cooling system and whatnot, getting up to about 220, a little bit above 220. Those 220, I've never actually get to 240 on my car. 220 on the track, I was noticing that I was getting pressure diving down to 60 psi,
which is much lower than it used to be.
Much lower, and on my engine, it's an EJ207, so I'm revving to 8,500 RPMs. So of course there's that concern, like, oh boy, this is, I don't think it's concerning as it's not low oil pressure given to like 30 psi, but
it's not ideal.
This needs some research.
Right.
And so I limited the revs and went back and figured, okay, let's see if we can understand what's going on here. So that was my first experiment on trying the shim.
Right.
So we took the 10 millimeter pump and we basically took two of these, right? Dropped two of them in here, put them back in, and for those who are familiar with this, the access port for this is actually right here.
It's on the front,
It's on the front, and you actually have to remove the entire front of the motor, the timing belt, the cover, the pulley, the whole works, just to do this 30-second operation.
And see, this is why I wanted to bring you out here, because you're the one that's crazy enough to do this actually a couple of times.
Yes.
And get data on it every single time. And so that's like this invaluable piece of information that I wanted to glean from you. So you put in the shim, so you're increasing the relief valve pressure, and what behavior did you see?
So initially, I didn't see any idle differences, right? I turned on the car, still saw about the same pressure. At street temperatures, I noticed that the pressure had gone up. I was seeing about 80 psi on cruise.
And you kind of expect that because you've now increased the maximum pressure the pump would deliver. So to see an increase in pressure in just normal street driving, that's kind of what you were shooting for.
Right. And of course, street driving, that's in the upper RPM range. That's not like at 2,000 RPMs. That's like 4,000 to 6,000 RPMs. Like, it seems to be holding pretty good. Now, as I started basically driving more spirited and introducing more heat, watching the oil temperature go up, I started noticing that the pressure was still going down some. And specifically, as I ran it through Redline, I noticed it was actually still hitting the same pressure it was without the two shims.
So you'd shimmed it, but once you get to full operating temperature, maybe at the track, you actually were not seeing any difference at higher RPM, but it was just kind of like at normal street driving, you were seeing the difference, but not when the oil was at full temp.
Exactly. I was seeing the exact same behavior. I was seeing the same pressure fall off.
Right.
And so for the users that are watching, that was actually modal 15W50. So
1550. So pretty thick oil.
Pretty thick oil in that sense. And of course, you'll go online, you'll see all the discussions of temperature and thickness and power, but I've had pretty good results with the 50 weight oil. I've run it for a long time, and again, temperatures, I never saw anything that was concerning to me.
Out of the ordinary temperature-wise.
Exactly. So this kind of led into, well, I really want to understand. I think I have a volume problem, of course, and I do. I increase the tolerances of the engine, the flow through through the components has changed.
You've got less restriction, less resistance. You've got basically a larger straw throughout the engine that the oil is trying to fill. So we increase the maximum pressure, but the 10 millimeter pump can only feed so much oil.
Right.
So now the next step was?
Well, so the next step on some people, if they would read, is add more shims. And I didn't think that was, I didn't want to try that because I think that was the equivalent of taking a garden hose and just squeezing the pressure tighter.
Right. Well, and
still the same volume behind it.
In the condition where you were most concerned, you had not seen any improvement with adding a shim.
No.
So that would also make sense. Well, don't add more shims because you weren't fixing the real problem area. Try volume.
Right. Let's see what the other pumps do out of curiosity. So I talked with John, and John sent me a 12 millimeter pump.
Yeah. So it went all the way to the biggest pump that's your remains.
Exactly.
Yeah.
And you know, this is now my gosh, second or third iteration that I have to take the front end of the car apart just to get to the pump, and of course make the mess. And I think the note you see this pump here, there's a lot of the Fuji Bond or RTV silicone around it. Really be careful and pay attention to how you're spreading this apart, because you don't want silicone to pass into these passages. On this pump, you can actually see it really bleeds into everywhere. And
it certainly can. And all it takes is a little sliver of silicone in the wrong spot, and you can starve something of oil.
Exactly. Yeah. So went through the process, stuck the 12 millimeter pump on, and took it out on the road. So
and the 12 millimeter pump, but you did not change the shim at that point, so it was just an off-the-shelf 12 millimeter pump.
Off the shelf, straight into the car. We didn't even open up the access port and look at anything. We just stuck it on the block.
So now that you've got the 10 millimeter pump, the 10 millimeter pump shim, what did you see now with the larger volume pump?
The pressure went up.
Okay.
So I was now actually seeing higher cold start pressures. So I went up to 100 psi.
Wow.
And once the engine warmed up, it was just below 85 psi. Okay.
So a fair amount higher than what you were seeing even with the shim 10.
Once the engine got to operating temperature, I'd level up at about 80 psi. And again, remember, I was seeing between 70, 75 psi in the old setup. So it's changed.
Yeah.
On cruise, it also stayed around there. Track temps again. Now it's getting the oil temperature up. What I noticed is that I actually still had a pressure drop, but it wasn't to 60 psi. I bumped it up. I'm seeing, with the same oil, I was seeing up to 70 psi.
Okay.
So now,
we've come up almost 10 psi with the larger volume pump, even compared to the 10 millimeter pump shimmed in that kind of problem area in the high RPM at the track.
Right.
Okay.
So I was certainly a lot happier with that, and at the track temps, it would still budge. It's just depending on how hot I start to get it.
Right.
I think it was safe to say I could see variation between 70 and 75 psi, not between 60 and 65 that I was seeing on certain conditions. So the whole scale moved up. It shifted to the right. So the thought was, well, let's try to shim the 12 millimeter pump. Let's see what that does.
So you still wanted to try and get a little bit more oil pressure there, because basically to try and match what you were kind of seeing with the temperatures and pressures with the original engine, with the original pump.
Right. Okay. Now, and my observations of the importance of having the two gauges, I never noticed high temperatures on the oil temperature gauge, even at 70 psi, even at 60 psi. I wasn't ever getting alarming temperatures. So I think as far as the aspect of am I actually supplying an adequate volume of oil to the engine? If I have too low of a pressure, I would expect to see heat, translated into temperatures rising.
Or if you had the pressure relief valve open all the time, you'd expect to see a spike in temperature because the oil is just cycling around the pump.
Exactly. So, for kind of just general comfort, I figured, well, let's see what one shim does in the 12 millimeter pump. Okay. And the one shim also brought the pressure up some more.
And even at our high RPM with the larger pump.
Yes, and in my case, I'm revving up through 8,000, 8,500 RPM. Right. So, there's a lot going on, and of course, for those watching, we can get really heavy duty into the details of the intricacies of the block and the oil galleys and flow and the bearings. But just in my case, the general observation, I from what I've seen from my pressure changes now, I know that given my setup, I'm going to leave the 12 millimeter pump on there versus the 10 millimeter pump in my case.
Sure. And the most interesting thing about this is, again, that you went with a 10 millimeter pump, shimmed it, 12 millimeter pump, and then shimmed it. And you've got, data to see that, what you had to do to get the change that you wanted to. And I mean, just a quick note, the significance of that pressure is because that oil pressure going through the engine, that's what's creating the cushion of the bearing for your engine, for the mains, for the rods. So where you have a target pressure, it's because that pressure is the cushion of oil between the, the crank and the bearing surface itself. So you want to have it be a certain target pressure because that's what is creating the bearing.
Yep.
But then it's just so interesting to see all of the information that you got as far as changing the different volumes and what you needed to do, making what seemed like a small change to get it back into what was the normal spec before you made that change.
Certainly.
And it kind of also highlights the significance of where you have to have those two key pieces of information.
Yes.
It's so important to know where you're starting so that when you make a change, you can make sure that you're changing only what you want to change and you're not like losing oil pressure, higher RPM or something like that.
I think it's, it's easy to say. So in my case, I built the engine myself.
Yeah.
I went through, measured everything, but I could have easily just went online and bought vendor X's short block that had specific tolerances and said, oh great, that's the stage X short block that I need for my race car. Assuming, well, that's the only piece I need. I'm just going to take my old pump, throw that on, and maybe not have some of the variables. Like, having information, the gauges, the sensors, the telemetry, all important stuff. So, take the time to, if you're not going to go through and toy with it yourself, make sure you certainly find someone to discuss that with.
Sure.
Because,
well, in the case of an engine builder, usually they will have a spec as far as bearing clearances, usually, and they should have some idea of what volume flow pump the engine is designed for. So that's definitely something well worth reaching out to.
Yep.
But in your case, making a motorsports engine that you made a slight change to, it was a pretty dramatic change that you had to make to get it back to normal, even with that looser tolerance.
And it's hard to say too what, if assuming I didn't have any of the gauge and just left it alone, it probably would have been okay for a while. Again, we're throwing details out the window assuming that, but trying to take some time and at least get some information about what the situations was. And over time I've learned a lot between oil pressure and oil temperature. I know that they both go in hand, and I even determine my oil choices based off those gauges. It's not snake oil. If I get an oil that's a specific weight, I expect it to handle at a certain pressure and see certain temperatures.
And because you changed the oil too with the 12 millimeter pump up to, was it a 2060?
Correct.
Yeah. So you went even a more even thicker oil, because the oil viscosity itself will have an effect on pressure and possibly temperature depending on the type of oil that you're running.
Exactly. And that was kind of a great experiment too, just to use as a point to see if there's any noticeable change. I also want to make sure that I don't have a mechanical problem.
Sure.
You could see oil pressure losses and perhaps there's a problem with the pickup. Right. So let's verify if we still make changes and we see no change, then we're probably something else we need to be looking at.
Right. And the key to it all is first to have the points of data, ideally before you make any significant change. So, and really I would say probably if you're going to be tracking your car a lot, an oil pressure and an oil temperature gauge should be right up there on top of the list as far as what gauges, what input you would want.
Yep.
But then also to have that good baseline of information so that if you make a change, even something as simple as oil weight, hey, do I still have the pressure that I want, or is it too much pressure, et cetera. And then, from that baseline, if you do make other changes, you can know, like, hey, I've loosened up my tolerances. I need to now consider, the type of pump that I'm using, or some of the settings of that pump to get, the pressure that I want at the temperature that I'm normally going to be running this car in.
Yep.
It all comes back to having that baseline of information so that you can make changes and do it smartly and hopefully get ultimately the best result and the longevity that you're looking for out of the car, and you don't get bit by changing one thing and not changing something else unknowingly.
Exactly. So. Yeah, every little piece. I mean, from, not even taking out the pump, just understanding the basics first. If I, with my last engine, I had spent a lot of time going through, and I knew what to expect. Before I spent any time with pressure, I spent a lot of time with just oil.
Right.
All right.
Types of oil, weights of oil.
I'm going up Pikes Peak, and we're seeing temperatures that I've never seen anywhere else, and I'm noticing the pressure's dropping. It's like
Right.
this, and the oil temperature is actually a lot hotter. Like, interesting. Let's go through and let's try out different weights. Let's try out different vendors' worth of oils.
Right.
I certainly have a different respect of the say of I use this oil and this is exactly why I use this oil, not more of because
Right.
"Oh, I just read on the internet that
Right.
that's a good oil. Well,
Right.
from my observations, it's been these gauges has shown me this change. I'm
Right.
going to stick with this oil.
And it's, running up Pikes Peak or having a motorsports built engine, that's where you can run into these circumstances where, what that car is, what the car is used for makes a big difference. And so that's where your results might be different than somebody else that's just driving the car on the street. But it all comes back to that baseline of information.
Right.
Like having that pressure and temperature information knowledge so that you can see, does this correlate with what I was expecting or not? If you try a different weight of oil. There's oil analysis too, but it just all comes back to that,
Yep.
getting a baseline, paying attention and knowing the car, and then trying something else and seeing what happens.
Certainly.
But there's so much about what you do with the car that's different that can change, the type of oil, the weight of oil that you want. Heck, the bearing tolerances. There's a reason that you win with a looser bearing tolerance, but it has to do with what that car is doing.
Right.
So there's a lot of variables just in how the car is driven and what it's doing, and then to a large extent too, the build itself. But it still all comes back to, knowing where you're starting, getting that baseline of information, and then going on from there.
Yep. And there was a lot just to taking this apart and kind of going through the pieces and seeing
Right.
what did it change.
Right, and that's where it's so awesome that you did that, so that you have some real world information for everybody to kind of know at least what you went through. And so if you've got the pump, the pressure and the temperature gauges, you can compare what you're seeing maybe with what you ran.
Yep.
And make a decision, do I need just another shim or do I actually need another pump?
Exactly. Or do you need to take your engine apart?
Right.
Right?
Let's hope not. Let's hope not. But cool. Well, Victor, thank you so much for coming down. Thanks for sharing the information, and thanks for doing all the work.
Certainly.
I know that it wasn't fun, probably the second or third time that you're redoing the timing on your car, but it's awesome that you did it. It's awesome that you kept track of all that information, and hopefully it helps somebody else out.
If you want me to change your oil pump in the next 15 minutes, I'm pretty good at it now, so.
Okay, 15 minutes. You're on the clock. Let's do it. Cool. Thanks, Victor.
Yep, thank you, John.
Thanks. Stay tuned.
Thanks.